Hello everyone.
I'm Anissa Nur Oktaviani.
I'm Aulia Rahma.
I am Ammar Arhab Abdullah. We are from Group 9 and then we are going to present our discussion about information retrieval, and our title is Personalized Movie Recommendation System Utilizing Content-Based Filtering and the Vector Space Model. Next, we jump to problem statement. We have 2 points in this part. The first is overwhelming movie choice. The second, ineffective traditional recommendation system. Movies are a combination of a visual, sound, and storytelling to deliver message to audience. With the rise of streaming platforms and digital libraries, many people have trouble to finding movies that suit their tastes due to overwhelming number of options. Traditional recommendation system, which focus on popularity or user review, often fail to capture the taste of users. To solve this problem, a more advanced approach was developed, namely content-based filtering that combined with the vector space model or VSM. This method analyzes movie features like genre, cast, director, and plot summarize to find and recommend movies similar to a user preference. But the challenge is in building an efficient system that effectively uses technique to improve user experience. The system uses a dataset about important movie details such as title, genre, cast, director, plot description. This data is cleaned and processed to handle incomplete or misinformation. For the example, the plot summaries are clean. Also, cast and crew data are converted into a list of names to find a film that matches their preference, so that the user can decide what movie they will watch without wasting more time.
And here I would like to talk about the problem solving. So the first one is we are collecting the metadata. We are collecting the metadata from the Kaggle that has 2 datasets. Well, for the first one is movie and the second one is credit. For the label of the movie dataset are budget, genre, homepage ID, language, popularity, and then the release date, revenue, and then the status, the title, vote, and so on. For the credit itself, the label are movie ID, title, cast, and also crew. So in here, the title, genre, cast, and director, also plot description were collected as the key feature. Next, we are converted JSON data because the cast and also crew fields are originally in JSON format. So we are convert into list of name. For the example, top 3 actor and also director, we will extract for the dash field. Then we are preprocessing the data. We are normalize the text field to ensure the consistency. We are removing the stop words to eliminate unnecessary word, applying stemming or lemmatization to standardize word into their root forms, and then we handle the missing value such as replacing the empty overview field with an empty string. For the feature extraction, we are combine the feature like multiple feature like overview, genre, actor, and director. We are merged into a single textual representation because in here the movie and credit dataset was merged by the ID of the movie and then the movie ID from the credit. And then the plot description and other text-based features were factorized using TF-IDF to quantify the word importance. And then the features like genre, actor, and director were represented numerically to facilitate the comparison and similarity calculation. Next, we are implementing the vector space model. Each movie was represented as a vector in high-dimensional space based on its combined feature. The similarity between movie was measured using cosine similarity because this one is allow the system to compute how close related one movie was to another movie.
Okay, next is content-based filtering. In here, we are personalized the recommendation. The system will identify the top and most similar movie based on the user preference or their favorite movie, and then the system will rank the movie by the similarity using the cosine similarity scores, ensuring that the most relevant films are suggested to the user. Next is the evaluation and optimization. The system performance is evaluated by using the precision, recall, and accuracy to ensure the recommendation align with the user expectation. Next is test with simulated data. So the system was validated using simulated data to confirm the correct functionality before the deployment. And then next is the deployment. The deployment itself is using the Google Colab interactive interface. In here, user can input a query and applying filter for the genre, actor, or director through intuitive widget-based interface. Next is instant recommendation. So personalized movie recommendation are generated in a real time, offering a seamless and user-friendly experience. That's all.
Now we headed up to do the conclusion of today's discussions. So the conclusion of this discussion is the personalized movie recommendation system utilizing the content-based filtering and the vector space model actively address the challenge of discovering films to individual preference amidst the overwhelming choices on the streaming platform. So our conclusion is the first, user-centric approach. So this is focus on the unique of the user preference by analyzing the specific attributes such as the genre, the cast, and also the plot descriptions. This personalized method would be significantly improve user satisfaction. And the second, the efficient data processing. So by the system employ the techniques like TF-IDF for feature extractions, this ensuring that the most relevant aspect of the movie are highlighted, which is enhance the accuracy of the recommendations. And the third, similarity measurement. So the vector space models allow for the calculating Gaussian similarity between the movie and rank them based on their relevances to a given movie. So this providing precise and targeted suggestions. And the fourth is continuous improvement. So the regular evaluation using the metrics such as the precisions, recalls, and accuracy allows for the fine-tuning the recommendation of the process. So this making the system adaptable to changing user preference over the time. And the last, this interactive user experience. By implementing within the Google Colab, the system interface support the user interactions. So this allow for easy input of the queries and filtering option to discover movies seamlessly. So that's all from our group. See you on the next video. Bye.